Welcome to the class, dear students. Today I am going to explain about the echelon form of a matrix. In order to find out the rank of a matrix, we have to reduce the given matrix into the echelon form. In fact, there are two forms in your syllabus. One is the echelon form, the other is the normal form. But to find out the rank of the matrix, we have done in my previous lecture. Just see that video, you can understand how to find out the rank of a matrix by just finding out the minor, and whatever the minor of the order of the minor becomes the rank of the matrix. So now when you say that the matrix is in the echelon form, when if it satisfies the so and so conditions, the conditions are here. And what do you mean by the rank? Means the number of non-zero rows is the rank of the matrix when the matrix is reduced into the echelon form. Now the echelon form means what? Whenever you are after reducing the given matrix, the zero rows whatever you have, that should be in the last row. It should not be in the first row. Okay, it should not be the first row or in the second row. Whatever you have, the last row is there. Your zero rows must be always in the last row. That is what zero rows always follow the non-zero rows is your first condition. Coming to the second condition, the number of zeros before a non-zero element in a non-zero row must be less than the number of such zeros in the next row. So this particular condition you will understand by seeing the examples. The first non-zero element must be 1 in every non-zero row. So these are the three conditions to be fulfilled to say that the matrix is in the echelon form. Let us now see the examples here. Now in this there is 1 0 0, okay, and this is a non-zero row, and this is a non-zero row, and this is a non-zero row. Remember that any row which has at least one non-zero element, that is also a non-zero row. Zero row means if the row is having all of them are zeros, then it is called as a zero row. So in this matrix only one zero row you have. And now coming to the matrix here, now there is 1, and here there is 1 0 before a non-zero element, that is 1 here, and first non-zero element is 1, before that I have 1 0. Don't bother about the zeros which are after the non-zero element. We are not bothered about these zeros which are after the non-zero element. Only before the non-zero element, how many zeros are there, we are counting here. But here it doesn't have any zeros. So it should come to the, so what is your first row? And of course when you reduce this, after reduction by using the echelon form and the elementary operations, actually this row can be changed as R4 minus R3. Automatically what happens is your last row becomes 1, 0 and 1. Okay, so now you can use the operations, and whatever you have that should come always in the beginning, and this 0 should be in the next row. Okay, let us see now this example. You have, this is a non-zero row, this is a non-zero row, all of them are non-zero rows because there is one non-zero element here. Now there is 1 0 before a non-zero element, there are 3 zeros before a non-zero element, there are 2 zeros before a non-zero element. Now in this case what should happen here is, of course this is your first row only, no changes. This is your second row because there is 1 0 before a non-zero element. Now there must be, see the second statement is what? Second condition is the number of zeros before a non-zero element must be less than the number of such zeros in the next row. So what should happen? This is your fourth row and this is your third row. Then only we say that it is in the reduced echelon form. Now coming to this one. Here this is the zero row, and this is a non-zero row, and this is also a non-zero row. But here you can use the operation R3 changed as R3 minus R2, so that you can do the operation and this becomes 0 0 and 2, this row becomes, okay. And now number of zeros before a non-zero element here, this is your 1 0, so this is your first row, and there are 2 zeros before a non-zero element, second row, and there are all of them are zeros, this is the third row. This is what the order of the rows, okay. Now let us come to this one now. How many zeros are there? 3 zeros, and here there is 1 0, and there are no zeros before a non-zero element here. There are again 3 zeros. Now the first and fourth rows are the same, so identical, so you can make them as this is also 0. Okay, now only the thing is this should come front and this should come the, what is your first row now? The first row is this, your second row is this, and your third row is this, and this becomes, after the operation this becomes 0, so this becomes a 4. Understood? Fourth row. So that's what it should happen. And then coming to this, what is the first row is no zeros before the non-zero element, there is 1 0, and here also third row should come, fourth and fourth row should come. This is of course the first row, this is the second row, this should be the fourth row, this should be the third row, because there are 2 zeros before a non-zero element. Here there are 4 zeros before a non-zero element. This should always go back to down. Coming to this one, there are no zeros, 1 0, 2 zeros, and all of them are zeros, and 0 rows have followed all the non-zero rows, so it is in the echelon form. I hope you could understand what is meant by the echelon form. Let us now start a problem. Now reduce this matrix into the echelon form to find out the rank of the matrix. So I just use one small condition here. What is that? Always try to make the 1 1 position. This is 1 1 entry, right? This 1 1 entry, make it as 1 always, and take the help of that and make the others are zeros. That is what the first thing. To do this, to make this as 1, I can divide the whole row by 2, correct? That becomes 1. But that row totally becomes some fractions, the other elements. So try to check whether there is 1 in the matrix. Yes, there is 1 here. If I interchange R1 and R3, I get my 1 in the 1 1 position, correct? So my first operation is R1 interchanged as R3. So it is 1 minus 3 minus 2. 3 minus 2, 4, and then 2, 3, 7. Okay, and now what you are going to do, you are going to change this element and this element as zeros, taking the help of this one. So what you do, your R2 is changed as R2 minus 3 times of R1, and R3 changed as R3 minus 2 times of R1. So let us do that operation now. Your first row will be as it is, 1 minus 3 minus 2. Now second row is, look at the second row. Your element is here what? R2 is 3 minus 3 times of, what is the corresponding R1 element is 1. So 3 minus 3 becomes 0. Are you getting? And then what the next one is R2. R2 is what here now? R2 is minus 2. So put minus 2 here. Minus 3 into corresponding R1 element is minus 3. So minus 2 plus 3 becomes what? 7. 9 minus 2, 7. This is 0. And next, what you have to do next? R2 minus 3 R1, the next position. What is that? 4. There is 4. So 4 is here. Minus 3 times of the corresponding R1 element is minus 2. So 4 plus 6 becomes 10. You got it? And then this operation is over. Now coming to R3. What is R3 here? 2. 2 minus 2 times of R1 is 1. So this becomes 0. Clear? And then what is the next one? Is 3. So 3 minus 2 times of corresponding R1 element is minus 3. So 3 plus 6 it is. So it is 9. And then you have the last element is 7. So it is 7 minus 2 times of minus 2. So that gives you 7 plus 4 is 11. So we write here 7 plus 4 is 11. So like this you have changed the given matrix in which your first column is having 1 0 0. So our job is to make the last row as zeros like that. So what do you do now? You can change R2 changed as R2 by 7 and R3 changed as R3 by 9. If you do this operation, what you get? Minus 3 by minus 3 minus 2 and 7 by 7 becomes 1 and this is 10 by 7. 9 by 9 becomes 1 and that is given by 11 by 9. Clear? Right. Now you have made now this element as 1. So take help of this one and try to make this as 0. So what is the next operation? R3 changed as R3 minus R2. So the value is 1 minus 3 minus 2. Second row is 0, 1, 10 by 7. Third row is 0, 1 minus 1, 0. Now 11 by 9 minus 10 by 7. So it is 77 minus 90 by 63. So it is minus, how much it is? Minus 13, right? Minus 13 by 63. Am I right? Yes. Minus 13 by 63 you get here. So that gives you minus 13 by 63. R3 minus R2 is giving you 11 by 9 minus 10 by 7. So 77 minus 7 9s and 9 10s, and this is minus 13 by 63. Correct. Now we are going to make this element and this element. This element will let us make it as 1 so that you will get the result. So the matrix is now this one. So let us now go to the reduce the given matrix into the next level. So what is that? Now I can change R3 as R3, and now actually no need to do any operation here. It's already understood that here in this step it's very much clear that you cannot make this as a 0. The only thing you can make is it's as 1. So R3 changed as 63 by 13, negative 63 by 13 times of R3. So your first row is as it is. Second row is 0, 1, 10 by 7. Third row is 0, 0. Minus 13 by 63 into 16 by 13, which is equal to 1. So it is in the exact echelon form. Now there are 3 non-zero rows. The 0 element before a non-zero element is 1 here. The zeros before a non-zero element is 2 here. So the number of zeros are bigger number of zeros is on the last. So that is done. First non-zero element in every non-zero row is equal to 1. So it's in a proper echelon form. So the rank of the matrix is given by the number of non-zero rows according to the echelon form. So the number of non-zero rows, which is equal to 3. Is that clear? So this is what about the rank of the matrix. I hope you could understand.